In this video, we're going to look at topic 19, example 3, systems with infinitely many solutions or no solution. Question is, what is the solution of each system of equations? So in part A, we're given the equation y equals 3x plus 1 and 6x minus 2y equals negative 2. So we're going to use substitution. Y is equal to 3x plus 1. So I'm going to replace the y value with the expression 3x plus 1. So we get 6x minus 2 times 3x plus 1 equals negative 2. We would then distribute, so 6x minus 2 equals negative 2. And we'll combine like terms. So when you subtract 6x minus 6x, those cancel each other out, they disappear. And we're left with negative 2 equals negative 2, which is a true statement, right? So that's true. It is an identity. So what that means is that there are infinitely many solutions. And if you remember when we graphed, what that meant was that these were the same line. Right? They overlapped. It was the exact same line, one on top of the other. And what you'll see, so we could stop there. That would be our solution. But the reason for that, right, equation 1, so we'll call this E1, is y equals 3x plus 1. If I take equation 2 and I isolate y by subtracting 6x, and I get negative 2y equals negative 6x minus 2, and then I divide everything by negative 2, well then y would equal 3x plus 1, which you realize they're the same, which is why they're the identity or an identity, and then there are infinitely many solutions. So although they're written in different forms, one is in slope-intercept and one's in standard form, if you put them in the same form, you'll realize that they are the same equation, they're the same line, so that's why you have infinitely many solutions. You wouldn't need to show this work down here, but that just backs up your kind of statement of why there are infinitely many solutions. In part B, let's look to do the same thing. So y is equal to 5x minus 4, so we're going to substitute that in for y. You do need to be very careful here, because we have 5x minus 5x minus 4 when you substitute that in. Sorry about that. Do make sure that you have that negative sign that'll then get distributed. So treat that like a negative 1. So you get 5x minus 5x plus 4. Right, that negative would be distributed in. So the 5x minus 5x cancels out, and we're left with 4 equals negative 4, which is not true, right? So that is a false statement. So that means that there is no solution. Right? And that's it. We would just say that there is no solution to this one because that is a false statement. 4 does not equal negative 4. And again, if you remember based on graphing, when we have no solution means our two lines are parallel to one another and they have different y-intercepts. So if I take equation 1, that 5x minus y equals negative 4, the screen's not cooperating with me today. And if we go back to equation 2, which was y equals 5x minus 4, if I put them in the same form, I get negative y equals negative 5x minus 4, and then I would divide everything by negative 1. So I'd get 5x plus 4. And what we want to notice here is that these two have the same slope, so they're parallel to each other. Right. The y-intercepts are different, which needs to be the case. If the y-intercepts were the same, we would wind up with the infinitely many solutions example, right? Because then they would be the same line. They're the same slope and the same y-intercept. So for part B, there's no solution because these two lines are parallel and they're never going to intersect. Again, you don't have to do this kind of bottom half of the work here. This is just kind of backing, not kind of, this is backing up our solution and stating why these lines either have no solution or they have infinitely many solutions. Okay, so an identity, like in part A, when you have a number equal to a number which is true, it would be infinitely many solutions. And in part B, where your equation doesn't make sense, so you have like 4 equals negative 4, that's a false statement, so there would be no solution. That's it.